Hi, I'm Luke, and I want to make a robot that can feed me my favourite chocolate snacks on demand.
My plan is to create a robot that can track my face and detect when I open my mouth. At this signal, it will then launch a chocolate directly into my mouth. The tools I have available for this project are some NEMA 17 stepper motors, an Arduino Uno, and a 3D printer. The software side of this project is fairly straightforward. I found a Python project, link in the description, which uses the dlib library to detect a face and output when the mouth is open. I then adapted this code to also output the X and Y coordinates of the mouth. I then passed these coordinates to the Arduino, which controls 3 stepper motors via L298N motor drivers. These motors will control the rotation, tilt, and firing mechanism of the robot. The chocolates I'll be using are Maltesers, and before designing the hardware I had to measure a set of these chocolate-covered balls of malted milk to find out the average diameter. I've made the mistake of relying on Google for the size of chocolate treats in the past, and I won't be caught out again. For the launch mechanism, I tried to create this spring barrel mechanism designed by Thang 010146. His channel is great for getting ideas for different mechanisms to use in projects. Unfortunately, my first attempt wasn't well enough aligned and had far too much friction between the moving and sliding parts. It was at this point that I realised that I was going to need to make quite a few iterations of this robot before I was going to get it right. I would therefore be doing a lot more 3D printing, and my loud Creality Ender 3 needed a bit of soundproofing. I placed the printer on a layer of concrete and a layer of foam to reduce the vibrations, and set about building a high-tech soundproofing chamber. For my second attempt at the spring barrel cam design, I printed the whole structure in one, increased my design clearances, and introduced some bearings to design.
I managed to get this design to somewhat work, but I had some issues during the print which led to a bit of warpage as it cooled down. As a result, nothing really aligns that well and it's still a bit stiff. The sliders do slide quite well under this elastic, but already this design was looking pretty bulky and getting heavier as I added more metallic components. I'd like to revisit this and see if I can make the design a bit lighter and more compact. For now, I think I'm going to take a look at some other options for the launcher mechanism.
One option was to use 2 wheels spinning in opposite directions to pick up and launch the chocolate. This kind of mechanism is commonly found in Nerf guns, Hot Wheels tracks, and tennis ball launchers. I had some quick success with this method, but ultimately decided against using it as it would require a separate mechanism to feed the chocolate into the wheels. It also used 2 standard DC motors, which strayed from my goal of only using stepper motors for this project. What I decided to use instead was a catapult style launch mechanism. I used a timing belt and 2 pulleys to ensure the stepper motor could create enough speed when activating the catapult arm. With this launching method selected, I designed and printed a tilting mount to allow the robot to aim up and down. I then mounted this using a Lazy Susan bearing onto a rotating base driven by a set of gears to ensure the motor had enough torque to spin the robot. To mount a camera on the robot, I simply used an old Android phone and an app called DroidCam to stream the video back to my computer over Wi-Fi. Unfortunately, the extra weight of the phone made the tilt axis quite unbalanced, but after confirming this could be sorted out by adding some mass to the back of the robot, I made an extension plate with some large nuts to balance it out. With the hardware all set up, it was time for the first test. The size of the steps I had programmed the motors to take were far too large, leading to the robot constantly overshooting while trying to aim. It did this with so much force that it once even threw itself off of my desk. With a bit of tuning, I had the robot happily following my face around the room, ready to launch some chocolate as soon as I opened my mouth. You might think that I look overly shocked that this actually worked, but that's because you haven't yet seen all the previous attempts.
honestly pretty happy with how this turned out, although there's a lot of room for improvement. I'd like to revisit this project in the future and try and do a few things a little bit differently. For starters, I'd look at changing out the stepper motors for servo motors to make for faster face tracking. I'd also like to make the whole robot smaller and more compact. Most importantly, this firing mechanism could be made a lot more accurate and a lot more reliable, and that's something I'd like to look into. As usual, all the code and CAD that I used for this project will be linked in the description if you want to try having a go yourself. Thank you for watching. If you enjoyed this video, please do check out my channel and consider subscribing. I've got a lot more projects in the works.